Hello students, good morning. So today we are going to discuss about magnetic field at an axial point of a current loop. So far we have come across only straight conductors. So now we are going to take a current carrying loop. Means generally in electrostatics we call them as the rings, but here the same ring, if it is going to carry a current, then we call it as a current carrying loop. Okay. So today we want to see what is the magnetic field at an axial point of a current carrying loop. So magnetic field at an axial point. Magnetic field at an axial point. At an axial point. Okay. Now here when we talk about this electrodynamics, that is moving charges and magnetism, related to Biot-Savart's law. So first we discussed about Overstate experiment. So Overstate experiment, I told you what are the important points. So regarding the Overstate experiment, I told you 3 points you have to keep in mind. Number 1, always the magnetic field line are perpendicular to the conductor which is carrying the current. Number 2 is the magnetic field lines are concentric circles around the conductor. And number 3, the magnetic field depends upon the distance of the point from the current carrying conductor. Okay, that is the 3 points that you have to keep in mind. But after that, mathematical treatment has been given by 2 physicists. One is we have the Biot and second one is Savart. Okay, so Baptiste Biot and Felix Savart, they individually worked to find a mathematical solution for the induction, the magnetic induction or magnetic field due to a current carrying conductor. But related to this Biot-Savart's law, very important point is we should know the vector form also. So before going to discuss this axial point magnetic induction, I will tell you in a simple way how to take that angle theta. We are taking sin theta, no? What is the magnitude we have taken due to a current element? So due to a current element, we know the magnitude of the magnetic induction dB is equal to, we have written as mu naught by 4 pi. This mu naught by 4 pi is like a proportional constant in physics, and it has been taken as 10 power minus 7. That is, mu naught is 4 pi into 10 power minus 7 into, we have written I dl sin theta upon r square. Right. So here what is meaning of this all elements? See, we have 2 quantities here, I dl sin theta and r. Suppose if it is a straight conductor, for example, you take a straight conductor. When we take a straight conductor, what is this r? It is very important here. R is the distance of the point where we want to find the magnetic induction due to this current carrying conductor. Okay, suppose this conductor is carrying current I, say upward. Suppose I want to find the magnetic field at a point P. Suppose this is my point P. First I have to select where is my origin. That is very important because position vectors, these are all vectors, isn't it? So when you talk about vector, first we have to select what is our reference point. Also we call it as origin. Suppose for example, this is my current element is here. So this is my origin. I am taking this is my origin, say O point. For example, there is a O point, a reference point. Now, when I join this P point to O point, this is we say the position vector of the P point. That is, OP is the position vector of the point P in the space, right? That means this we write as R vector. That is our R vector. So when you select that, when you draw that R vector, there must be an origin. That is very important. The reference point must be there. So because when it is a straight conductor, there won't be any issue here. You don't have any problem. But when it is not a straight conductor, when we are talking circular loops, like for example, now we are going to take up that article, we have to select first where is the origin. Means where is our reference point to draw that position vectors, isn't it? So for that, now see that Biot-Savart law what we have done. This is our origin, this is our position vector of the point. Then what we have done is, we have taken shortest distance from the point where we want to find the magnetic field due to this current carrying conductor. So this we have taken as D, shortest distance. That shortest distance won't change, but R can change, because whenever this point changes, R value is going on changes, and whenever my reference changes, R value is going on changes. So where is that theta now? What is that theta value? Theta is the angle made by my position vector with the current element direction. So this is my current element direction, isn't it? I am taking, this is my IDL, my current element vector. This is my current element vector. So this position vector is making an angle with our current element. I told you current element is similar to a charge in our electrostatics. Whatever the effect of a charge in electrostatic, same effect will be produced by IDL here. Their charge at rest, that will produce electric field, but here IDL is the current element that will produce a magnetic field at our desired point. Okay, so that is meaning of this theta, and that is the angle what we have taken sine of that theta. So that is very important here. Now in vector form, see how we are going to write this now. So it is equal to, we can write now, this is magnitude. So what I have to indicate now? I have to indicate what is the direction of this dB, means that magnetic field. For that, we know already we are going to use a unit vector, because unit vector will indicate the direction. Therefore, we will write like this: dB vector is equal to mu naught by 4 pi into I dl is a vector into sine theta into R unit vector. R unit vector divided by R square. So that R unit vector will indicate the direction of the magnetic field at the point P. So how it comes in vector form now? That I can write like this also, because what is our unit vector? How do we find the unit vector? So mu naught by 4 pi into I dl, this sine theta. R unit vector is R vector divided by magnitude of R vector. Therefore, this I can write R vector by magnitude of R vector divided by, what is this R? That is also same as that magnitude of R vector. So when it comes to this form, it will be like this now. So mu naught by 4 pi into, we can write now, see this, IDL sine theta, R we have no. So this we can write now, IDL cross R vector divided